they allow us to do crazy things because they've already said it's okay to consider some of these things. And often they write with real hard nuts and bolts bases. I love science fiction that's rooted in reality and is an extrapolation from what we know to what we don't know, but we can imagine. This freedom to imagine is just priceless. Now, Paul Barron has a wonderful metaphor that he describes. People have given him credit, as they should, for very early explorations of the idea of packet switching. But Paul says anything like this, anything like the internet, is kind of like a cathedral. And somebody decides they're going to build a cathedral. Now, you have one guy over here, and he lays a brick, and he thinks that's the most important brick in the cathedral. But somebody else puts another brick over here, and someone else carves a gargoyle. And somehow each one of them imagines that the thing that they put into the system was the most important part. But Paul pointed out that you need all of those pieces or you don't have a cathedral. And that's what internet has been like. It has been a place where everybody gets to create a brick, put it in place, and build this continually evolving and growing infrastructure. So we've ended up with an ecosystem. It's a technical ecosystem with all kinds of moving parts. It's an institutional ecosystem. There are people in this room who make things like the Internet Society, the Internet Engineering Task Force, the Internet Corporation for Assigned Names and Numbers, and all the other ISTAR activities work. They're all critical to making the ecosystem function. And in addition to that, there's a social infrastructure which has grown out of the Internet. In fact, the reason that the Internet Society was called the Internet Society is a lot of us believed a society would emerge out of this spreading Internet, and I think you're seeing that with the social networking that's going on now. So Clarke dreams up satellites in orbit. He dreams up space elevators that can bring us up into orbit a lot less expensively than having to push ourselves up with chemical rockets. And he says to us, what happens if you can do that? Figure out how to do that and let us move ahead. Alan Kay is another wonderful guy, and he has another wonderful quote. He says, the best way to predict the future is to invent it. And I think Alan got that one right. Some of you will recall that, in fact, on the back of his biography that was just written, he said that any sufficiently advanced technology is indistinguishable from magic. And I think as this 21st century unfolds, we're going to see more and more things that look like magic, but they're not. What they are is the product of engineering. I'm an engineer, and I'm proud of that, because engineering is turning science fiction into reality. Thank you.
The speaker, I will. We'll invite a few questions if you'd like to present them now. Come on, come on.
Oh, we've already got one right back
Oh,
there.
we got one. May we hear it?
Well, let's see. The first problem is, how many engineers does it take to turn on a microphone? Well, there's a gentleman here. Mr. Ordway, would you like to ask a question?
Fred.
I read recently that an internet millionaire, Silicon Valley, is buying huge quantities of books. Have you heard about that? He does not trust how we're going to preserve, and he wants to make a Library of Congress in the West. Do you know about that?
Well, I don't think that, first of all, there are two things to say. I don't know who that individual is. I know that Brewster Kahle is working very hard to preserve as much of the internet as possible. He's also scanning lots and lots of books, just like we are at Google. I can understand someone wanting to accumulate some of these more permanent, at least more permanent than digital copies of things. I really worry right now about digital content. If you just think for a minute about the complex objects that you create every day when you create a word processing file or a spreadsheet or some other complex object. Think about a video game for a moment. That's a lot of software. It's uninteresting unless there's a computer that can interpret the software and interact with you and present all the scenes. So these complex digital objects are only useful if there's software around to interpret them. The problem, as I see it, is that there's no guarantee that that software will survive. For example, a new version of the operating system comes along and you're sort of compelled to implement that, and nobody made a version of the game or the processing software to interpret the older objects. There's never any guarantee that there's backward compatibility. I call this, for short, bit rot, because what happens is that the bits that you have that you've carefully preserved and you move from one medium to another are rotten if they can't be interpreted. So I have this worry that by the beginning of the 22nd century, our descendants will wonder about us, and they won't know much because they won't be able to interpret this gigantic pile of digital rotten bits that have accumulated. This is a non-trivial exercise, a really hard problem. There are intellectual property issues associated with preserving people's software or getting access to the source code. What happens when a company legitimately says, I can't support this anymore? What happens when they just go out of business? So there's a big problem here, and all of the wonders and utility of digital copies of things still leave us with this potential problem. What we need is the moral equivalent of digital vellum, something that will last for a long, long time. We don't have a solution to this problem yet. And when I go to universities, I try to remind PhD students there that there may be a dissertation hiding in the solution to that problem. Thank you, Mr. Ordway. Good question.